All right, so we're going to start the next unit. There's about 4 or 5 sections that we need to do. I'm skipping the first one because that would have taken 2 or 3 days in itself. So we're going to do the easier parts of the unit, which are also the most important for you anyway. Okay. So 14.2 is about the binomial theorem and Pascal's triangle. So we'll start with Pascal's triangle because it's actually pretty easy. The triples? No, not for this. Okay, but you do need to know how to make the triangle. And here's the only part that you really have to memorize. Top row is a 1, middle row are 2 ones. To get the next row, you add 1 and 1 together, which makes 2. You put it down in between, and you always put 1s on the outside. And then you add 1 and 2 together, which makes 3. 2 and 1 make 3, and you always put 1s on the outside. You kind of see how that works? So the next, I'll show you. The next row would be what? 4 here, 6, 4 with 1s on the outside. And it goes on forever and ever. Okay? Now here's what I would like for you to look at. So that's Pascal's triangle. And now, if I asked you to figure out what a plus b to the 0 is, you all would say that that was equal to 1. And now if I asked you to do a plus b to the first power, you would say
a plus b.
Yeah, it doesn't, just 1, right? What about a plus b to the second power? Foil it out, what do you get? Plus? Okay. And what if I asked you to do this one? Well, I'll be nice to you. I'll just write out what it is after you foil it out. You get a to the third plus 3a squared b plus 3ab squared plus b cubed. Hey. It's going well. You're now a guest on my video lecture.
Oh, that's excellent. You have a protractor.
A protractor?
Yeah, I'm doing some math today.
Oh, very nice. If there's not one in here already, there's several in the math office.
Okay, just go there.
Yeah.
Cool.
They'll hook you up.
Thank you.
Yep.
Thanks for having me as part of your
No problem. Okay. So this is obviously just 1, right? What are the coefficients of a and b here? A 1 and a 1. What are the coefficients of a squared and b squared? A 1 and a 1. Same thing here. Notice anything? 1, 1, 1, 1, 1, 1, 1, 2, 1. There it is. 1, 3, 3, 1. Does this kind of make sense here? Okay. So, let's use this. Oh, maybe you shouldn't put the baby on the floor.
She is also now, I guess. Stab it. That will make it stop. Shake it.
So here's what you should know about the binomial theorem, or the Pascal's triangle. These numbers represent the coefficients in the expansion of a binomial. Expansion meaning, if it's a binomial to a power, you can use these to kind of take a little shortcut. Instead of having to FOIL it out and spend a few minutes doing it, you can use these numbers and look for a pattern here, and I'll show you what the pattern is right now. It's probably easier to see it with the square and the cube than it is up here. What power of a do we start with? Squared. And now a is to what power here? And then a is to what power here? 0. So a goes from a power of 2 to 1 to 0. Do you guys see that? What about b? B starts with the power of 0, goes up to a power of 1, and then up to a power of 2. You guys see that? Same pattern here. A starts at 3, goes down to 2, goes down to 1, and then there's none of them. B starts with none, no b's in the first term, b to the first, b to the second, b to the third. Does that make sense?
Yep.
All right. So here's an example of how to use the triangle. Let's go ahead and expand x minus 2y to the third power. And it might be helpful to go back and label the triangle again. This applied to what exponent? 0. This applied to an exponent of 1, 2. Do you guys see what I'm saying here? So if you want to do something to the third power, you should be looking at the fourth row. It's always one row higher than the exponent. Does that make sense? No, because if the exponent is 3, one row lower would be 2. It's not a literal thing. Like the number of rows, first, second, third, fourth, right? So which row do I look at here? Fourth row. So here's what I like to do. You look at your fourth row, which is 1, and then all you're going to do is take whatever is in the A spot, which is x, and we started out with the highest exponent, which is going to be 3. And then we also have a negative 2y to what power? To the 0 power. It always starts, the first letter or the first variable starts out to the highest exponent. The second term, which is negative 2y, is to the 0. And then now we just follow the pattern of the triangle. What's the next number? 3. And now I just decrease the exponent of x and increase the exponent of negative 2y. You guys see how that's working? What's the next term going to be? Plus 3, and then what? X to the first, negative 2y to the second, and then the last term is plus 1, x to the 0, negative 2y cubed. Are there any questions on where I'm getting all these exponents and how I'm writing this out? Okay? You don't just leave it like this, though. Now you actually have to figure it out. Okay? So this is going to be just x cubed. Does that make sense? Plus, actually, it's not going to be a plus, because I have a 3 times negative 2, which is negative 6 x squared y to the first. Does everybody see where I'm getting that? And now here I have a 3. I'm squaring negative 2, which makes this 4. So it's plus 12 x to the first, and then y is squared, right? Last term, x to the 0 is gone. What's negative 2 cubed, though? So it's minus 8y cubed. This would be your answer.
How come we didn't learn this in the beginning? We should do it.
Guys, one question at a time. Raise your hands. Yes. To help you expand binomials, yes.
How come we didn't do this in the beginning, like before we learned all this stuff?
Because this ties into something that we haven't done yet. Sabrina? Okay. We good? Okay. Now, here's what I mean we really haven't done too much of. Factorials. We did a small little lesson when we reviewed probability before the ACT. So I'll just kind of write down what we know. This is not a very excited n. This means what?
N times whatever. N times n minus 1.
So let's write it this way.
It was like
What is for sure going to be in the multiplication? 1 times 2 times 3 all the way up to whatever n is. Okay? And we also had the definition that 0 factorial was 1. And we'll do a quick example. 4 factorial means to multiply what?
Yep.
Which is? Okay. Looks familiar, yeah?
Yep.
Okay. Now, here's where it's going to get a little bit weirder because we haven't done this too much. You should now be able to simplify things with variables. Okay, and here's the best way to write this out so that it actually visually makes sense and your answer is pretty easily found. What do we always start with when we multiply? 1 times 2 times 3 and so on, right? Well, where is n plus 2 in relation to n?
There it is.
Where is n plus 2 in relation to n? Is it before or after? And how many numbers after or before? 2 after. Very good. So this is, does it make sense that I'm going to continue going up to n, but what comes after n? N plus 1, and what comes after n plus 1? N plus 2. So this is what n plus 2 factorial would look like. We still do everything we normally do, but now we're just going 2 numbers higher than n, which are n plus 1 and n plus 2. Because that's always there. What's that? Well, then it's just 1 times 2.
The bottom would be n times 2.
Because we don't know what n is. Okay? So now, what does n minus 1 look like? Same thing, but do I go all the way up to n here?
No.
We stop 1 before. Does that make sense? All right.
How do you put the n?
Because we stopped 1 before. That's what n minus 1 means. For example, if n were 10, I would stop at 9, because 10 minus 1 is 9, right? Now, where is n minus 1 up here? I didn't write it in, but where would it be? Right before n. You guys see that? So now, it's pretty easy, because from 1 through n minus 1 are going to cancel, because that's all multiplication. And then all I have left on the top is n times n plus 1 times n plus 2. We know what n plus 1 times n plus 2 is, and we can certainly distribute an n to get our simplified answer. Okay, does that make sense so far? Should we do another weird one like this?
No. Sure. Fine.
Okay. Just think about everything in terms of n. That's the easiest way to do this. n minus 2, does that come before or after n? What about n plus 1? Write it all out. So 1 times 2 times 3, etc. N minus 2 is where I stop. And you guys all said that this is after n, right? So wouldn't this include all of this? If it comes after, wouldn't it include everything that came before? Absolutely. So this is the same. And what comes after n minus 2? N minus 1. What about after that? And then? N plus 1. Up here? Because it doesn't go up to n minus 1. It only goes up to n minus 2. Oh, like right here? Because n minus 1 comes after n minus 2. What would come before n minus 2? N minus 3 would come before. Does that make sense? And then, yeah, look, everything here cancels. So what's left on top?
0.
Not 0. 1. And then it's just these 3 multiplied out. I'm going to put them in a different order so it's easier. Because we know what n minus 1 times n plus 1 is. What is that? That's n squared minus 1. So then that's all over n cubed minus n.
We're never going to have a negative, right? Like a negative parenthesis n minus 2.
No. Okay? This is a good place to stop. We're not going to finish today. We'll finish this tomorrow. And then you'll have tomorrow to finish the packet.
Homework?
No, I guess not.
Dude. Hey.